All right, hi everyone. I think it's just about 5 o'clock, so we can probably get underway. So my name is Mark Needham, so I work in the developer relations team at Neo4j, and I'm joined by David Dyball. I guess you can introduce yourself as well.
Yeah, I'm the Devops Engineer for Artfinder, which is an online art marketplace, sort of helping individual artists sell their work and get representation on the internet, I guess.
Cool. So what we're going to do this week, we're going to try a bit of a different format. So some of our previous weeks have been more completely presentation based, where we've had one person present for most of the time, and then we've mostly done questions at the end. This time we're gonna try something a bit different. So you'll have to let us know how we get on, what you think, what you like, what you don't. And the idea this week is we're gonna basically, David and I are gonna go back and forth in a more interview based approach, I suppose. And we're going to talk about what David's been working on with Neo4j. So if you have any questions, so I've got some questions obviously that I'm going to ask. If you've got any questions that you'd like me to ask or that you'd like us to talk about, put them in the YouTube chat or put them in the Neo4j Online Meetup chat in the Slack. Only other thing, so the structure is going to be mostly an interview, and then David's going to present for 10 or 15 minutes, probably about 20 minutes in. And when we get to that point, if you can't see the slides really clearly, try and change your YouTube settings to have 720p as the resolution, and then it will probably be much more visible than in other resolutions. Okay, so with that, let's get underway then. So. Right, so we can see from the background, you've obviously you work for Artfinder. So do you want to maybe explain a bit? So what do you do for anybody who's not familiar with Artfinder?
Cool, yeah. So I like to explain it as we're like Etsy, but specifically for artwork. We're individual makers of art, whether it be sculpture, paintings, photography. They can sign up, set up almost like a shop front on our website. And sell through us without having to have all of the technical expertise of running a website. And we'll handle all of the promotion and things like that for them. So yeah, we're basically just trying to champion the little guys, because the art world is kind of one-sided. You know, the 0.5% of all top-selling artists in the world. You know, it's not really got it's not that it's not sustainable, but I think, yeah, individual artists, they struggle to sort of break into mainstream, and everyone really deserves to sell artwork. So that's probably what we're trying to solve here.
Cool. Okay, and I've put a link to the website into the chat if anybody wants to have a look at that. So you mentioned in the initial introduction that you're a DevOps engineer. So what does that mean? What type of work are you doing on Artfinder? So do you do?
Yeah, it's kind of the little bits of everything kind of role. I'm not quite a developer. I leave that to the experts. But I work a lot on integrations. So especially when things like Neo4j came along, other things, Elasticsearch, all of our AWS infrastructure, I'm in charge of sort of managing that on a day-to-day basis and integrating that in our workflow. I will get my hands dirty with some code, but it's usually surrounding integration projects. So writing all the scaffolding and stuff for Neo4j implementation was probably one of the bigger projects that I've done.
So I suppose that leads us to the obvious next question: is how did you end up with the project to try and integrate Neo4j into Artfinder?
So I guess the initial push came from the fact that we grew as a platform, and it's just become much more difficult to sift through. I think there's about just over 500,000 products published on the platform available to buy. If you're a visitor to the website, you're not going to sit there and go through 500,000 artworks. So primarily we wanted to look at ways of narrowing that down based on your preferences and your input, what you viewed, things like that. Build a recommendations engine. and there was a couple of routes that we could have taken with that. One was collaborative filtering on top of Neo4j, which is what we've gone for. And then there was, obviously the machine learning aspect of things as well, which is not exactly off the cards, but it would be a supplemental add-on to what we have with Neo4j. So we really just wanted to narrow down the 500,000 artworks to maybe, if you've got the patience to sit there and go through 600, then good on you. A lot of people, when they're shopping, aren't going to want to sift through vast amounts of things. They want a very quick way to find the things that they like. And so I guess we were just trying to solve that artwork problem. And I guess the domain itself is very specific. Artwork is kind of a unique thing. If someone's searching for stationery, you could throw a stapler at them and they would be, not physically a stapler at them, but you could put stationery in front of them and have a good chance that they would find that relevant. But artwork is a very subjective medium. You've got people that will only like abstract, people that will only go for photography, sculpture is what they like, and for as many people as there are, there's individual unique artworks. So trying to slim that down and make it a bit smarter, and get the right things in front of people was probably the end goal.
Yeah, and so I think so. You mentioned a few other ways of solving the problem. So did you? What was your approach? Did you already have an existing solution for recommending art to people, or did you spike a few, or what was the approach?
So initially, it was all search based. So we're also running Elasticsearch as our main search backend, and we were just running some fairly hefty queries. They're not in terms of performance, but just in size and the data we were throwing into it to get things back. We weren't exactly tracking user behavior, so it wasn't tailored to individual users. It was more of we think that this has, a certain propensity to interest at least a few users, things that are on sale and, the basic things that many websites have been doing for ages. So I guess we wanted to move out of that very, that one-off recommendation for everybody to much more user-defined. This is specific to you. This is what we think you'll like.
Okay, so that's kind of the rather than like caching, like going and I suppose would you say pre-calculating the recommendations and then showing them versus trying to like work them out on the fly, or is it not quite as simple as that?
It's even simpler than that. Unfortunately, it was very it was literally just one search query that would run across, and it would say, these are the things that have sold. These things, are by the same artist or published on the same day. It was very rudimentary sort of data points that we were selecting artwork on, and it was.
So you're kind of like showing the most popular. So sort of type recommendations, okay.
So we do have like a like system built in to the website where you can favorite your artworks that appeal to you, and so we would take global popularity, but not necessarily popularity based on your preferences. It would be popularity based on everyone on the site, which it's not individual recommendations.
Okay, and so what made you think, maybe we can? Like did that work? Like those recommendations where you were suggesting the popular things, or what made you want to try something different?
I think our philosophy of every artist deserves to sell, and every person deserves to have unique artwork in their home. It requires that we surface the right thing for everybody, and we also get artists' artwork in front of people. So this generic sort of mass popularity option only really put, again, we were repeating, the wider world's sort of ideas on popularity serving art. So we wanted to work sort of in opposition to that. We wanted, the little guy deserves to sell as well. It's not just the most popular one. And I think especially
makes sense.
With individual recommendations, the surface area that we can cover is much wider.
And so is it the type of, trying to think, is it kind of a long tail type thing where there's lots of there tend to be few pieces of art that everybody likes, and then there is like very specific ones that different people like, or how does it really look?
To be fair, we're getting our recommendations at the moment with what we have implemented, and it's providing great results. But in terms of analysis of the data we have, that's like the next phase. That's something we're still looking at. But especially visualizing it actually in the Cypher browser, you see some really cool clustering. You know, like this particular artist appears at a center of this mass group of people, and you know that's a really influential artist, and you can actually see, you know, just visually at a glance, some very interesting things. So the data can definitely speak to us. We've just got to dig in and do the analysis.
Okay, so cool. So roughly, idea is we want to try and pull out, like, get as many artists in front of people as possible, rather than focusing only on 2 or 3. So once you decided that you wanted to try and make some progress towards making that happen, how did you go about? And you tried a few different things, and you decided, okay, I want to try. I think Neo4j is the one we're gonna use. What was your approach to learning it? Like, had you used it before, or what was your learning approach?
So I guess my first introduction to Neo4j was I saw a colleague at a previous employer. He was just doing a visualization demo, and the easiest way for him to do it was to just put dots on the screen with Neo4j, and it wowed the people he was presenting. It made it very easy, and so that was the first time I saw Neo4j, and I was like, okay, put that in the memory banks. And then we sort of came along to this question that we wanted answered at Artfinder, and we were looking at the different technologies, and it really was a matter of what did we have the most experience with, and what did we have sort of what was the quickest path to product, basically. So going down the convoluted neural networks, machine learning implementations, you know, that could take quite a lot of time, and personally I have very little experience with that so far. So it would be a whole new set on top of that. And just in sort of, we were weighing up the options, looking at Neo4j, and oddly enough, I became the champion for Neo4j in the office, because I took one look at Cypher and I just went, I know this, I understand this. You know, I'd be the person that would stare at an SQL query and my brain would dribble out my ear. But for some reason, Cypher just works. I mean, it's a visual representation of exactly what you're trying to do in the graph. So I sort of was sold straight away. And then, you know, we saw that the ways you can implement Neo4j, we can start to solve the problems or the questions we have. Mm-hmm. So just sort of, it took a fair amount of back and forth sort of implementation, experimentation. But eventually, yeah, the collaborative filtering, that's worked out wonders for us.
So for anybody who hasn't come across that term, do you want to quickly give a few line summary? What is collaborative filtering?
Yeah, so collaborative filtering is, simply put, it's I like this, someone else likes this, they also like this, maybe I will also like that.
So in this case, this is the piece of art.
Piece of artwork.
Yeah, I like that piece of art. You like it. I like this other one. Okay.
Yeah. So it's a really good way of exposing things that someone may not have interacted with yet, and getting that onto their radar, which is exactly sort of the problem we're trying to solve. So it's it's quite you know, from a data science perspective, I believe that, you know, it's been used for forever in a day, but sort of it just seemed to answer the question we needed it answered at the time. So we immediately jumped onto the Neo4j blog. You guys have even got a full end-to-end written implementation of basic collaborative filtering, which is, you know, gave us our head start, and we just started implementing that.
Okay, so that was reasonably easy to take that and adapt it to your domain.
Yeah.
So I guess the other thing that people I've found people come across when they're first getting into graphs is they try and obviously the first two things you have to do is you have to get your data in, and then kind of in combination with that is often, well, I got to work out how do I model it in this format. So is that what was your experience I guess we can start with the modeling bit and then move on to the import.
Yeah, the modeling one was interesting. at first, I was just thinking as simple as possible, user, product, artist, and how they tie together. And we basically just had one relationship between all of them. A user can like an artist, a user can like an artwork.
Mm-hmm.
We quickly found that we absolutely destroyed performance just by not separating out into different sub relationships and things like that. So iterating on the model was probably I wouldn't say the hardest lesson learned, but it was the biggest lesson we learned, was that you really got to think about your data model. I guess we're kind of blessed. We write in Python, and migrations are fairly easy, and we're doing them all the time as part of our deployments. But then we came to this, and it's like, oh wait, we need to rethink the whole graph. We need to figure it out. And I guess coming back to the data import, finding a very repeatable way of importing your data over and over again in case you do need to iterate on the model was a really big step for us as well. So I guess we have all of our graph at the moment is all delayed task. So nothing queries at real time. We've got caching layer in between it, so we can actually lose the graph for, I mean, I wouldn't want to leave it offline for an hour or so, but we can lose the graph and the site will happily sing along, which is a nice way to be. It's a nice little buffer. But because of that, we can use the Neo4j import to do raw CSV imports, and that thing is lightning quick. We're importing the entire graph in 3 minutes. It's just ridiculously fast. So the ability to sort of script that and get that infinitely repeatable was a big step for us, and it worked really well.
Cool. So I reckon we've probably led ourselves to the point where it would make sense to have a look at your slides where you explain the model. So I'm gonna so let me. So I think you should now have the ability to share that part of the screen, hopefully.
Yeah. I've done my slides. Sorry, folks. That's the old one. One moment, please, caller.
Cool. So if you have any questions while we're setting this up, obviously feel free to answer them. I'm not seeing any at the moment, so I guess we're good so far.
We've answered all the questions, Mark.
Yeah.
There are literally no more questions. Alrighty. Can you do it directly from in here? I guess I'll just do a screen share. That works.
Yeah, I think that's working now. Cool. Yep, there we go. All right. So what we got here? So we got this is the model that you said. This is the attempt number 1, I guess.
Yeah, this was our very first sort of work at the graph, and it was about as simple as it could be. And sorry, that's just loading. Yeah. Actually, if I just jump out, yeah. So yeah, it was literally just single relationships between users, products, artists, and it was really good as an introduction. The second we started actually throwing some heavy queries at it, it got unwieldy very quickly, simply because the differentiation between likes and likes towards an artist and likes towards a product was too generic. So we actually ended up splitting that out. This is almost a verbatim copy of the example on the Neo4j blog, this query, and it works fantastically and it gives you quite amazing results. But it was taking us 18 minutes to run against all of our users, against one user, which was a bit too long. I think, if we wanted to run across our entire user base, it just became untenable completely. But the basic idea was matching users, finding everything that they like, and then from there finding everyone else that also likes at least one of those items, and then fanning out again at a third layer and finding things that the starting user doesn't necessarily already like. And then based on how many times that appears in different relationships, you give it a weighting count, and then obviously the higher weighted it is, the more likely we would assume you are to like it. So yeah, it's a fairly cool query, but it was sort of giving us a lot of grief in terms of initial performance, and that was mainly our implementation and the way we were thinking about it, also with the amount of data that we were throwing at it. So yeah, we had to do a fair amount of optimization and back and forth. So I mean, one of these queries would touch just about the whole database, which was yeah, too many nodes, especially when you're iterating over the whole database once per every user. So we sort of had to figure out a way to do that, and actually jumped on the Slack channel and spoke to Michael about this problem. Sent him some snapshots of our data, and it turned out we were actually hitting a supernotes issue, and we had some users that just had a ridiculous amount of individual likes. Basically, they'd effectively gone through and clicked the love heart button next to absolutely everything on the website, which yeah, it's bizarre behavior from a technical standpoint, but that's what they did. And basically, we
just sorry to interrupt you a sec. So just for those of you who haven't come across it, the supernode issue is where you have lots of things connected into one node. Is that the idea? Or?
Yeah. So we had we would start with one node, and then all of the relationships off of that. You might be, I mean, some of our highest ones were 200,000 or more relationships. Okay. And then if you think for every single one of those relationships, you're fanning out again on the end of that relationship. So you would go from user A has a similarity to user 72 or whatever, and then user 72 might like another 200,000 products themselves. So you actually end up traversing 400,000 products for simply touching two nodes. And it was yeah, it's more of a data issue than it is a Neo4j issue. So we ended up actually just doing an exclusion on that. Any user with over a certain threshold of relationships, it sort of breaks the percentages as well. You're going to find that the data you get out of someone that likes everything on the website is going to be very hard for you to suggest them anything useful anyway. So we ended up just filtering those out, and it wasn't actually that many users. I think of our entire user base, we maybe had 200 or so users that had a massive amount of relationships connected to them, and yeah, I mean it wasn't like it affected all of our users, which was handy. Otherwise, we probably had to work around it some other way. So yeah, we ended up limiting the scope of all of the likes as well. We figured, for initial implementation, taking our data set, and even if you had likes 200,000 products, we would just look at 400 and say, okay, well those 400 are the most relevant because they're the most recent. And that also adds a level of not necessarily randomness, but it does allow it to evolve over time. Things will change as you like more. Your recommendations will come through differently, just because it acts like a first in, first out queue. So, the 400th item in the list will get popped off when you add one more, and as a result, your recommendations will shift. Might be subtly, might be, quite significantly, but it does add that evolving aspect. A lot of the guys I actually met at the Neo4j Meetup were talking about randomness and how important adding randomness to recommendations is, because it's an odd thing that a user can tell when they're being recommended stuff. Even if it's an unconscious thing, they start to draw parallels between what they've clicked on before. So I mean, we've all done it on a like Amazon or something, just because I looked at something, all of a sudden all the recommendations are based on that. A level of randomness helps to blur that deliberateness of recommendations as well. So we found that to be both beneficial in terms of the amount of data we were processing, fixing the supernodes issue, and also adding subtle blurriness to the relationships.
So for the likes bullet point on there, to keep the most recent 400, does that mean that you actually go and are you only keeping 400 per user in the graph, or do you put a timestamp on the relationship and then filter based on that, or what's your approach there?
So there's a couple of ways that we could do it. The way we're doing it at the moment is we're literally only storing 400, which, I mean, I think that might put us at maybe 600 million relationships or something. I don't know. We do have quite a lot of likes, even with that sort of hard limit of 400 per user. We're still storing a hell of a lot of relationships. I mean, ideally, from a data standpoint and from a precision standpoint, it'd be great to store everything they ever liked in the graph. But we already have that data in a relational database because the like system was implemented a couple of years before we even looked at Neo. So it's all backed off of all the data, comes from an RDBMS. So yeah, it's easy for us to just do a first in, first out queue in the likes. And that's just a simple Cypher query with a skip that you literally find all the likes, skip the first 400 and then drop everything else after it. And we just run that every time we do an insert for a new like into the system. We just run that query first. So just in the batch, it trims and then it adds one more, which is nice and quick.
Cool. So all the data that you've talked about on these last two slides, that's all been, I suppose, taken from a relational database and then converted into format for the Neo4j import tool, and then you've run that and imported it into the Neo4j database. Yeah,
so we're just doing a nice couple of PostgreSQL dump commands to dump out CSV format files, and then just importing straight from there.
So you don't have to do any transformation off the Postgres output to get it to work with the Neo4j import tool, or is that a reasonably similar format?
Absolutely nothing needed to be done other than making sure that the queries were performant enough. You know, if we left it to the Django ORM to get it to export the data to CSV, it became a little bit unwieldy. But one of our SQL gurus in the office came up with some nice queries that basically get that data out very quickly and just put it straight into CSV files. And I think the batch file that we've got to basically redo the entire graph might be about 50 lines. So it's incredibly simple, which was it made it really easy for us to add new relationships. So as we iterated on our model, adding new relationships or maybe new node types, we ended up being able to just modify that import tool or the wrapper around the import tool very quickly.
So when you were doing these, actually, we got a question which I think you might have answered already, but I'll have to check. So Adam's question is, what method did you use to limit the scope of the recommendation to users with 400 likes? So I think if I summarize it, you can tell me if I got it correctly, is that we're taking the most recent likes that users have done, and if they've got more than 400, then it will filter some of them out. And if they've got less than 400, then obviously they'll just have less than 400. Is there anything add to that? Or?
Yeah, no, it is. So it's a pre-calculation or a pre-trimming. So everything we have is running through an asynchronous task queue. So we just queue things up, and the first thing that runs would be, this user has just updated something. So trim all of their stuff to all of their likes to 399, and then expect another one to come through in the next transaction. So, I mean, you could batch those into individual transactions, but it just worked out easier for us to separate the two. But yeah, it's literally, we just make sure that there is always 400 relationships for each user when we do a new relationship creation. So it's not necessarily at query time when we're querying for recommendations, when we're saying, find me some recommendations for this user. We're not doing the limit there. Originally, we tried to do the limit there, but it didn't actually solve the problem we were trying to solve. And we were still hitting too many nodes, too many relationships, and the traversal was just taking too long. So yeah, it was easier for us to sort of separate that out into a subtask, I guess.
Cool. I don't think there's any more questions. I'll probably I think that was all I could think of for here. So I'll let you carry on presenting.
Yeah, no worries. The other big win for us was actually splitting the so the initial. If I go back a slide, no, too far. So this initial query. Can you see my cursor? Probably not.
Yeah, I can see it.
Okay, cool. So this initial part here, where it's finding this similar user, forget that last line there, but those first two lines are finding all of the users that are similar to you in some way, because you like the same things or you follow the same things. We actually decided to split that out into a completely different relationship, so we could pre-calculate those. And that was a big win for performance. And we could do that periodically. So once we know that these 200 users on the website are most likely to influence your decision, just because they have such high weighting, we can usually rely on that for a longer period of time. We don't need to recalculate that every time. So we could do that, once a month, update everybody's user-to-user relationships. We ended up calling that user is similar to user, just because it was nice and easy to follow, which I think I've written just here. So users connect right back to other users through this similar to user relationship. So what that actually meant is that we could actually limit quite a number of the nodes and traversal that was being done at the start of the collaborative filtering query. Make it, it was tenfold faster, I think, just because we could do the pre-calculation as slow as we wanted to, as long as everybody had at least n number of similar to user relationships. The query would always succeed and return results, which made it very easy for us to build up those relationships over a prolonged time, rather than having to get all that data in there before we even began using the graph. The other thing we did was split out. There's different interactions that you can do to an artist and a product. So you would follow an artist like you would follow someone on Twitter, and you would buy from an artist. So the bought and bought from, they were two additional relationships. We figured that they actually weigh quite heavily on your decision on whether or not you like something. I mean, if you've bought something from an artist, you can probably safely say that their other artwork is going to appeal to you. But not only that, any user that has also bought from that artist, you would trust their recommendations more, because obviously you share something, you share artwork from an artist that you've both bought from, which in the next query, actually, if I jump forward, we're doing these cases where we can pass in a weighted dictionary based on relationship types. And what that actually allowed us to do was iterate over a series of different weights in our code. We could just at query time pass in different relationship weights and get completely different results until we found what actually worked, which was really good. So because all the Cypher is obviously in our application anyway, our implementation is very hard coded almost. It would take a code release to change the queries themselves. But this dictionary of weights that's just here, we could iterate on that in real time and test out different values, which made things really easy to sort of find out what was useful. There was a lot of back and forth testing to figure out, if I've bought from something, bought from an artist, and I bought a specific artwork, those are much stronger than if I just click the like button. Obviously you're showing a lot more interest if you paid for something. So yeah, it was quite a neat win for that one, was to just be able to iterate across the weighting system.
So those on that query, if you just go back one sec. So on the query, that the curly brackets weights in there, just for that's a parameter that you're passing in. Is that right?
Yes, yeah, that and limit to things that we can change on the fly.
And so in that weights
yes.
parameter, it's basically like a map where the key is recently liked, and then there's a score associated with recently liked, recently followed, bought from, and so that's to take into account that different actions basically have a different weighting. Exactly,
yeah. And then in the case statement, we can just default to a value of 1, whereas if you bought something and someone, it might be 5. It just allows for that differentiation of actions, but all in the same query, which we found really useful.
And so were you using to pass, so presumably this query would this be being executed from, you mentioned at the beginning you were using Python, so were you using one of the Python drivers to do that, or?
Yes, yeah. So we started out using Python Neo, and then that was replaced by, well, not necessarily replaced, it's still going, but there's now the Neo4j Python driver, which is using the Bolt protocol, and actually that's been a big win as well. Using that's got us thinking in a much more graph-oriented way. So yeah, just one of the native drivers. I mean, we were able to pick that up and implement it with little to no difficulty at all.
Cool. And then I'm trying to think if there's anything else in the query that's might be tricky. And so that, I guess the only other bit is the case statements. In there, is that similar? Did you find that's quite similar to a programming language case statement? Or?
Yeah.
But any gotchas?
Gotchas, not so much. It was more realizing that we actually needed to do it twice. So this happens for 2 different relationships. So the first relationship is me to an entity, so a product or an artist. How much I liked that. If I bought from them, then I really, really liked it. And then the second one is more the other user from the other end of the relationship, how much they liked it. And the combination of the 2, we just did in a sum. So we could do 2 separate case statements for both relationships, and then from there we could add them together and get a nice round number at the end that told us, how prominent this relationship was. So I mean, if I bought from someone and you had bought from someone, then we probably share a very strong similarity in taste. Yeah, cool. So I mean, this pre-calculation, it saved us a lot of time on our queries, and yeah, I think it was the right way forward, because it's still separating out the pre-calculation of similarity versus the actual fetching of recommendations allowed us to treat them in 2 completely different ways. So the dictionary or the map, sorry, you'll have to excuse me, I come from Python, so it's dictionary.
Yeah, we can go with dictionary. I'm probably saying it wrong.
No, it is a map. It's I guess it's particular to everybody's preference, but so we could pass in different weightings values depending on whether or not we were calculating similarity to users or actually calculating the final recommendations. So we could change these values for both, and sort of just treat them like separate entities. So similarity, once the plan is to just further extend this down the line, but not just for recommendations, but user-to-user similarity has a big play in, I mean, it can be used for marketing analytics, figuring out different cohorts of users, figuring out, well, this group of users, if we start to run clustering algorithms on things over this similar to user relationship, we could start to extract a lot of very useful data. So I think it was actually, in hindsight, it was a good decision. But it was more out of necessity at the time. We were just struggling to get the execution time of our queries down. So splitting it out into something that could run every so often, and then have the recommendations run, every single time they were needed. It sort of just made sense. But that's me in the middle there. So that's all of my recommendations, all of the users that are similar to me. So again, we store, a number of those, a hard limit. I think it's at about 400. But yeah, it sort of, now that we have these relationships in here, we can very quickly, in terms of the actual query time in Neo4j, figure out my relationship to every one of these users, in the smallest fragment of execution time possible, without having to do any of the actual case statements and things like that. So it definitely made it a lot easier. And again, every time we run these, we literally truncate a lot of them. We remove them and say, okay, we're going to give you a fresh start and see how we go. And so again, that evolving, or the idea of evolving recommendations over time. Maybe we were similar 2 weeks ago, but I've gone on and liked a lot more other things. And it's something that perhaps you haven't engaged with all of those products, or followed those artists. So we diverge a little bit on our tastes, but there might be, again, other users that are much more similar to my recent tastes. So it's an interesting evolving thing. I mean, from a data perspective, I'd love to store things indefinitely, and have all of these relationships forever and ever and ever. But I don't think it's feasible at this point. I mean, we could export it and archive it off, but in terms of real-time queryability, it would be, probably wouldn't be very performant. So yeah, that's the similar to user. That was the first stage of sort of refactoring this whole process, and then this is the actual final recommendations, and it's fairly simple. There's only a single case statement. Again, we can pass in a completely different list of weighted values, and get relevancy scores based on that. But again, we've replaced the entire first part of the query with this simple, similar to user lookup, which is where a lot of the speed came from. An interesting thing for us was finding that if I've already bought it, then it's probably actually not something I need to have recommended to me. So whereas, I bought this and another user bought something similar, we have a strong connection. If I'm actually being recommended something, I don't want to see things that I've already bought.
Yeah, so I'm sure you've probably had the. I recently bought like something from Amazon, and then everywhere you go, and they're like, "Hey, you should buy this thing." And you're like, oh,
yeah, exactly. Yeah. And so this weighted dictionary that we implemented allowed us to change that and really start to see what actually worked. And in a lot of ways, I mean, we ran a lot of A/B tests on the website, with different weighted values for each segment of the A/B test.
Oh, that's interesting. So what were you doing there? Were you doing like the same query, but just feeding in like
different weights for each one? So
nice.
Group A would see something where bought was boosted a lot more. Group B would see something where recently liked. I should point out there might be some difference in the slides. Recently liked is actually just likes now, but anyway, that might just be different through some of the slides. But anyway, whether or not you like something, or someone else liked something and we're recommending it to you, might be more important than whether or not it was purchased.
Yeah.
So yeah, being able to test this in a repeatable way, was really important, and it still is. I mean, we could sit here and change it. I mean, you wouldn't change it every single day in an A/B test, but we could, iterate on this until the end of the world, and we'd continue to get useful information out of it. I mean, there's not that many iterations that you could have there. There's probably 5 variants that we could do in terms of different weights, but yeah, it made it very easy for us to test this out in a repeatable fashion, which was great.
So have you done any tests where you tried like completely different queries, or have you focused the point of difference is always the injected as parameters?
So at the moment, it's injected as parameters. That's the main thing we've tested. Once we start to look at more, so when we're going to, so this is future work, so it's not really thought out too far, but the cluster analysis stuff is something that I would really like to start running against the graph, figuring out segments of users that exist, and then finding out what products are similar to those. There might be a different collaboration algorithm we can use there. It would still be collaborative filtering in a sense, but instead of this user-to-user recommendation, it would be something like this user belongs to this segment, segment 235, and segment 235 might get these recommendations. And it would be interesting to see whether or not broad spectrum recommendations, well, they're not even broad spectrum. I guess the original search query we were doing was broad, but these wider scale recommendations would have any difference, and the ability to test either of those against each other, would play a large part in figuring out which one worked. But something we want to do. But at the moment, it's all the iterations been done here in the weighted dictionary. I don't know. I don't think there's too much else in that query. It took forever to just iterate on this and wrap my head around a lot of it. As easy as I found Cypher in the beginning, it starts to get it can get very technical. So there was a lot of time spent on Slack talking to everybody in the Neo4j users and the help.
Yeah, I guess the only other difference you've got from the previous one is you're on the second line. You've got a star ... 2.
Right. Yeah. So to a depth of 2. So anywhere from one relationship, sort of one direct relationship to possibly 2 relationships away. So that allows a bit more fanning out. Because we were doing the hard limits on the number of likes, it allowed us to sort of be a little bit arbitrary around how definite that value is there. So it wouldn't be bad to test whether or not, like another weighted dictionary, if we had relationships here as well. I mean, take a bit of refactoring with an optional match and things like that. But being able to test, different weights for the strength of this first cohort user to recommended product, or cohort user to recommended product to another product. So it'd be interesting to test that variation out, but that'd just be a little bit of tweaking, I think, to this. But for the time being, we were happy with just saying, okay, well, to touch a lot more products and to compare a lot more products, let's just fan out to a scale of 2 relationships away from the starting point. And it seems to have, it's giving okay results, but again, more testing will tell us over time whether or not it's working. So again, there's the weights dictionary. This is a super simplified. I only picked out 3 of my similar users. So this is me, and you can sort of start to see which things are going to be most important. So this product here, I've obviously purchased this product. So in terms of recommendations, that's actually going to have a less significant sort of relationship. Whereas actually me to this user, based on the similarity. It's very small, sorry, you can't see that. Similar to user. So me, similar to this user who likes this product, which was made by this artist, which this user also likes, is actually going to end up being quite boosted. So it could be very, it'd be interesting to see what that one is and how relevant that actually ends up coming out. But again, this is with the nice visualization thing. You just run a couple of queries on a limited set of data. So you just add in some hard limits and you can start to see some really interesting things. And it just gives you a whole nother way to see the data that you're working with, which I found super, super beneficial. And actually this one here, this user has bought a lot of things from this one artist. And actually the weighting of that relationship for that artist will actually be a lot less significant just because it's boosted by this user here. And it's only one user that has all of these relationships. So it's, yeah, it's only through visualizing this that you can sort of see that wait, this is actually unimportant and we should probably treat it as such. So, iterating on your queries and then going back to the visualizer and seeing it that way is very helpful. And I think at the last meetup you showed, was it iGraph, the Python library?
Yeah. I think we were doing some PageRank stuff using that. And
so iGraph, you can pass in some really, really large amounts of data and it will happily just spit something out. I found with the in-browser sort of graph view, once you turn off autocomplete, it's a little bit more performant, but I actually managed to crash my browser a number of times just trying to push the limits on how many nodes I could display at once. Whereas iGraph will give you a nice static JPEG at the end of it. So, things I learned. I just tried to sum up a bunch of things that were really helpful. And I guess, iteration was the biggest one. Being able to just continuously refine things and realize that, oh, wait, that wasn't right, or I need to change this, or what if we tried it this way? And just getting into that mindset of not trying to get it right the first time, or accepting that you're not going to get it right the first time and just keep going. But definitely saving yourself some headache by building iteration into the process of developing any sort of model or query. And the other one was help from the community, because you guys are so active on Stack Overflow and on Slack, and I could email. I think at one point I was having back and forth with Michael and Christoph from GraphAware, who's always on the Slack channel. Everyone is just so ready to help and interested in solving problems, and it was just a different way for me to learn was to talk to other people about it rather than just try and fix it all myself and then keep my findings to myself. So definitely lean on the community. That was an awesome benefit. And go to meetups. Meetup's great. And then this is what I want to do in the future. So this is just like a couple of things that I've been brainstorming. Storing things like page views and seeing whether or not that affects either cohort generation, probably not cohort generation, thinking about it, but generating actual recommendations. Maybe recently viewed does come into it, but again, you want to avoid the Amazon thing of showing you a toothbrush just because you looked at a toothbrush once. So it'll be interesting to see that. And then the other thing is a lot of relationships that we can pull out from the artwork itself that are very specific to our domain. So things like style, subject, category. There's so many more that we're looking at going into. And this relationship here, we're doing a lot of work at the moment on visual similarity, which is a lot of feature detection, image descriptor, extraction from images, and storing that in the graph and making that a numerical value that we can weight and sort of sort based on that. It's a no-brainer to have it in the graph and just be able to use it again. So the future's going to be fun.
Cool.
Let me jump out of this and give you back control.
All right, great, cool. So guess we're about 5 minutes from the hour. So while we wait and see if anybody's got some more questions from us, I'll just talk a little bit about what we're going to be doing next on the online meetup. So I've posted some links into the chat. And if you've been following the Neo4j blog, you'll have seen there was a post about APOC Awareness Month. So for April, we're doing an APOC competition. So if you haven't come across APOC, APOC is the awesome procedures on Cypher. So this is a package of different procedures and functions that you can drop into Neo4j and then use those in your Cypher queries. And we're doing a competition to see who can come up with the coolest ways of using those functions. And next week, Michael and I, and probably a few others, we'll do a meetup where we focus on the questions people might have for that competition. And I guess we'll probably even do some demoing of interesting uses that we've seen of them. So if you want to come along to that, it's this time next Thursday, so 13th of April.
APOC is super useful. There's a lot of the advanced sort of clustering algorithms ready to use there, which is which is actually the stuff you went over at the last meetup with the social network analysis. Great.
We've got a question from Adam. Which I guess we can probably take a few questions while we wrap up. So this one is: what kind of numbers were you using for weighting? Which weightings did work or led to higher conversion?
Right. So I'd be lying if I said I knew what the weightings were, but they're more. It was less important what the values were. It was more the difference between the values that mattered. How much something is more important than the other relationship. So I mean, the default value of 1, and then bought from, you could have a weighting of 1.3. Bought something. Well, I really like that because I paid for it, so I maybe that's a 5. I liked something, maybe that's a 4.2 or something. But it was just a lot of testing to find out, especially figuring out the purpose of those relationships. Was sort of, we didn't understand those relationships until we started testing them and seeing that, oh, we changed this, and actually, you know what, I find this more relevant, which can be kind of subjective in testing. But then I guess that's where your A/B testing comes in, just testing many different iterations of these weightings and sort of seeing which ones perform better. Our conversion rates were things like, whether or not the person actually just engaged what we showed them. So, we've got a recommendations page. So if I take the screen, I'll show you the daily recommendations page.
I'll give it back to you.
I got it. Yeah. So if I go. Is where I do something and the demo gods frown upon me and everything crashes.
It's a high risk closing maneuver.
I'll just wave at my boss. I'm sorry. So these are recommendations for me based on the things that I like, and so we'll spit those out. Once a day. We'll generate you some new ones, and actually. I'd have to say it's working quite well. A lot of these are me. Maybe not that seagull, but a lot of the abstract stuff is definitely me. So whether or not someone clicked on this would be a conversion. Just the fact that they clicked on it because they found it engaging was a very simple conversion metric. Actually, one more thing that we've just chucked into the graph is there's more like this button with all those image features that we're doing. The actual query to run against the image engine takes far too long. So running it against the graph should be faster, but I broke the internet. No, or just the website. All right, demo gods hate me. Sorry, guys. So I mean, putting lots of things in the graph makes a lot of sense now. But yeah, just playing around with those weightings, that was the most important thing, figuring out what was important for us. So I mean, I could give you random values, but they may not apply at all to your use case. You might find that, you know, a certain type of relationship weighs much more heavily on what you want to put in front of the end user.
Cool. Well, I reckon that's got all the questions, so we can probably wrap up for today. So thanks to everybody for joining. Obviously, thank you to David for taking the time to present what you've been doing to us.
Awesome. Yeah, thank you. It was
Cool.
great.
All right. Thanks, everyone. See you next time. Bye.